surface roughness, surface flatness, and waviness. We're seeing more and more people requesting these kind of measurements after cylinder heads and cylinder blocks have been machined. And Chuck, I'll hand it over back to you.
Sure. With modern gaskets, MLS gaskets, they're all stamped steel, so they don't have the soft materials that are accommodating of roughness and waviness that we used to be accustomed to, with conventional style head gaskets. And those gasket types are out there, but by and large, from an OE standpoint and even in high performance, we've moved to MLS gaskets. So can you go ahead and advance, Anthony? Um, Back one.
There.
Yeah. So these are some Stylus types. So roughness can be measured with a skidded profilometer. Waviness can only be measured with a skidless profilometer. So if you look at the stylus that actually contacts the surface, that's a really good indicator of what we're looking at as far as skidless versus skidded. The skidless, if you'll back up one slide, you will see the drive unit has to be supported too. It cannot lay on the surface that you're measuring. So the drive unit and the stylus are going to be different to be able to measure waviness. So let's go ahead and advance to why it matters. Um, the flatness is the ability for the gasket to meet the surface, and cold seal materials can only stand up to so much. So if I have a truly out of flat surface, it doesn't matter how much high tack or copper coat or whatever, if combustion gases can squeeze through there, it's going to ultimately blow that stuff out. Now, in the drag race world, when you take the stuff apart a lot, you can deal with it. But when it comes to longevity, then you really have to address the issue of waviness. So let's go ahead another slide. Roughness, again, the cold sealability is one of the biggest issues that you're dealing with. We used to want a little bit of grip and bite in the gaskets, but most of the OE stuff now and racing with MLS, you can be really pretty slick. And will ask, can you be too slick? We won't take enough time to get too slick because you have to do some polishing and lapping, and that's just not going to happen in most of our machine shops. So you don't really have to worry about getting too slick.
Sorry.
If you back up that one slide, we're
Sorry, Chuck. There we go.
here. Yeah. So that kind of gives you a little bit of an idea of what the gasket would be seeing versus roughness. So all of the up and down little peaks and valleys, is your waviness, or is your roughness, I'm sorry. But if you look at the red line, that's kind of usually what generates waviness is the equipment. It's the rigidity of holding the part. Maybe it's bearings in the machine or something of that nature. So it's a whole different thing than just your cutting insert. Go ahead and advance and kind of remember this. If and Mark Malberg from Digital Metrology shared this. Sorry, I don't see his logo on there. It covered with the formatting of the slide. But so if basically the dimension of your thumbnail or fingernail, if you can see stripes, that's waviness. That's not roughness.
Yes.
So that's very, very important. I've seen a lot of shops where you can see a head laying on a bench and it looks like it's a rainbow. So if that's the situation, you need to look closer and see if you're seeing those indicated stripes, and that's going to be waviness. So you need to make some adjustments to take that out. Impacts of waviness, again, I always say try to think of it as like the suspension bridge. Um, that metal gasket is not going to go down into those areas and fill that void. So now it's like looks like a suspension bridge and you have a leak path underneath of it. Again, those polymers and what, it may not leak water, but it's ultimately going to leak combustion because combustion forces are too high and they will push that stuff out over time. So factors that can impact your roughness and waviness. Um, PCD works terrific for aluminum, but will fail quickly on iron. So buying the right tooling, it gets expensive, but we definitely should try to use PCD on aluminum because it does work so much better. CBN can work for both cast iron and aluminum, but as I was talking about, some of the high nickel materials will stick to the carbide cutting insert. You will see the same thing. The aluminum will bond itself to the CBN and then it starts to smear. So you lose your edge condition. The choice of edge prep, so you can have dead sharp inserts, you can have lands, A land, T land, a soft tone edge prep, or whatever. All of that can impact how your surface finish is as well. The sharper, the better, but your inserts don't last as long. So that's why people will go with things like an edge prep. Machine setup to include level, secure feet, head clamping, the X-axis conditions, your gibs and waves, the drive motors, lead screws and bearings. Just machine condition is super important. And one of the things that we see in the automotive machine stuff is when we mill head surfaces, they're not 100% flat anyway, because we tilt the cutter head so that we don't create a back cutting. If you have an excessive cut, you put a cup in the gasket surface. So usually that spec's going to be 1 to 3 thousandths tilt from the over the length of the fly cutter. So if you have beyond 3 thousandths, you're starting to get to the point where you could potentially cause gasket sealing issues. Well, we don't measure long enough with a profilometer to see something like that, even if we were measuring for waviness. So that's something check on your machines and make sure that you maintain that. And then if lastly, spindle speed and feed rate are always going to impact your surface finish or your roughness, because that's the very first thing we're going to do is, okay, if I need a smoother surface finish for my MLS, then I'm going to change my feed rate so I don't advance across the part so quickly. Um, Measuring again, so here's how you isolate the stylus from the part. So this is just an example of a profilometer that has a stand that you can actually bring that device down. You can set the cylinder head or whatever you're working on underneath, and then you can measure that. So it's not influenced by the topography of the part. It's strictly, mapping the surface uh, without, again, being resting on that part.
So just to finish off this section, this is an example of a modern technology surfacing machine. This machine has been developed with specific bearings and spindle design and precision ball screws and thrust bearings so that factors like waviness are very, very small, very accurate. And as Chuck mentioned, the setting up of the cylinder heads. This is a close-up picture of a fixture, and you can see the number of supports and clamps to hold the cylinder head rigidly for machining.